The restless giant of Orion high above us, on the shoulder of Orion the mighty hunter, glows a star unlike almost any other in the sky. Betelgeuse. It is not just another point of light. It is a cosmic beacon that has fascinated human beings for thousands of years. On a crisp winter night, when the air is clear and the stars burn sharp against the darkness, Betelgeuse is one of the first stars your eyes are drawn to. While most of Orion is traced with cool white and icy blue stars, Betelgeuse burns differently. It shines with a fiery, crimson glow, warm, alive, and unmistakable. This red tint sets it apart, and it carries with it a story, a warning of a star in the final stages of its life. Betelgeuse is not steady like our sun. It is wild. It flickers. It brightens and fades, restless as though it knows its end is near. Classified as a red supergiant, it belongs to one of the most massive and short-lived families of stars in the universe. To imagine its scale, picture this. If Betelgeuse were placed where our sun is, its swollen edges would reach out across the solar system and swallow Mercury, Venus, Earth, Mars, and perhaps even Jupiter. One single star, large enough to consume worlds whole. Despite being cooler than the sun on its surface, its vast size makes it tens of thousands of times more luminous. It is a giant whose power and brilliance defy human imagination. And yet, this brilliance comes at a cost. It burns quickly, and it burns violently. Humanity has never been blind to this star's presence. Across civilizations and centuries, Betelgeuse has held special meaning. The very name, Betelgeuse, traces back to Arabic, translating roughly to the giant's shoulder. In ancient China, it was revered as the emperor's star, thought to embody imperial power and cosmic authority. To the Greeks, it was fixed into the constellation Orion, the great hunter who still strides across our skies each night. To many cultures, Betelgeuse was more than just a star. It was a sign, a symbol, a mystery. Ancient astronomers paid close attention to it. Some described it as ruddy, deep red like blood. Others recorded that it once appeared more yellowish, suggesting that within human history its color may have shifted. This is rare. It shows just how unstable this star has always been. Even without telescopes, early skywatchers noticed its strange, flickering brilliance. Betelgeuse seems alive, breathing, pulsing, swelling, and shrinking in cycles that last years. Its brightness rises and falls, sometimes subtly, sometimes dramatically. It is as though the star has moods, reminding us of its unstable nature. Then came late 2019, when Betelgeuse astonished the world once more. Its glow began to fade, and not just a little. Its brilliance dropped so dramatically that anyone who looked up at Orion could see the difference with the naked eye. The star that had always blazed like a beacon dimmed to just 1/3 of its normal brightness. The world took notice. Social media lit up with speculation. News headlines shouted the same question: was this it? Was humanity about to witness the long-awaited supernova of Betelgeuse? For astronomers, this was both thrilling and terrifying. The end of a red supergiant is always sudden, always violent, and always spectacular. Telescopes around the world, and even orbiting in space, turned their gaze toward Orion's shoulder. All eyes, human and mechanical, were fixed on the crimson giant. What they found stunned even the experts. Betelgeuse had experienced a massive surface eruption. A colossal portion of its outer layers had been violently hurled into space. That expelled gas cooled and condensed, forming an immense cloud of dust that temporarily blocked the star's light from our view. From Earth, it looked as though the star was dying before our eyes. But Betelgeuse had not yet reached its end. This was not the final collapse, but it was a warning, an unmistakable sign of just how unstable and unpredictable the star has become. The giant of Orion is restless, shedding its layers, breathing in and out, and reminding us with every flicker that its time is running. Countdown to a cosmic finale inside Betelgeuse. Deep beneath its glowing surface, forces of unimaginable power are at work. Long ago, the star burned hydrogen in a steady process, just as our sun does today. But that fuel has been gone for millions of years. Now Betelgeuse burns heavier elements. Helium into carbon, carbon into oxygen, oxygen into even heavier matter. Each stage blazes more violently, and each lasts a shorter time. The star is racing headlong toward its inevitable collapse. Eventually, iron will form at its core. Unlike lighter elements, iron gives no energy when fused. At that moment, the balance between pressure and gravity will shatter. Gravity will seize control. The core will collapse in less than a heartbeat. The outer layers will crash inward, then rebound outward in a cataclysm of unimaginable force. The result will be a supernova, one of the most powerful explosions in all of existence. Unlike our Sun, which still has more than 5 billion years of life ahead, Betelgeuse is only about 10 million years old. And yet, its life is nearly over. This is the fate of massive stars. They burn fast, shine bright, and die young. Ancient astronomers recorded strange changes in Betelgeuse, noting its shifting colors and its cycles of brightness. But nothing in human history compares to what awaits us when this giant finally reaches its end. When Betelgeuse collapses, the night sky will transform forever. From its distance of 640 light-years, the explosion will blaze brighter than the full moon. Some astronomers even believe it could be seen during the day, glowing like a second sun. For weeks, perhaps even months, the brilliant glow will dominate our skies. Slowly, it will fade, leaving behind a newborn nebula, a vast and colorful cloud of gas and dust stretching across space. In that single instant, Betelgeuse will release more energy than our Sun will generate in its entire 10 billion-year lifetime. But this cosmic event will be more than just a spectacle of light. It will unleash a flood of neutrinos, ghostly particles that pass through matter as though it were air. It will ripple the very fabric of space itself, sending out gravitational waves that detectors on Earth will capture. For the first time in human history, astronomers will be able to watch a nearby supernova in exquisite detail. The James Webb Space Telescope will peer into its fading light. Hubble will trace its aftermath. ALMA and the Very Large Telescope will track its expanding nebula. LIGO, Virgo, and IceCube will listen for gravitational waves and neutrinos. Together, this global arsenal of instruments will allow us to witness every stage of a star's death. Scientists hope to answer questions that have lingered for centuries. Will Betelgeuse's corpse become a dense neutron star, or will it collapse further into a black hole? How are the heaviest elements, iron, gold, uranium, born in these explosions and spread across galaxies? Betelgeuse's death may finally reveal the answers. And yet, one mystery remains unsolved. When will it happen? The star could explode tomorrow. It could explode in 100 years. Or perhaps not for another 100,000. Until that day, Betelgeuse continues to pulse, shimmer, and breathe in and out, like a cosmic heart beating down to its final moment. And when that moment comes, the universe will give us a farewell beyond imagination. A brilliant, fiery curtain call. A final gift from one of the greatest stars to ever